Hey everyone, and welcome to section 2.5 on solving linear inequalities. In this first video, I just want to talk about describing inequalities. So let's look at x greater than 4. This is a sort of vague statement, but if we want to think about numbers that satisfy this inequality, x has to be greater than 4. And you can see that being greater than 4 means that you're going to the right. So all of the numbers to the right of 4 satisfy this inequality. And we know that 4 itself does not, because 4 is not greater than 4. They're equal to each other. If I wanted a way of writing down this picture, I can use this notation. This is called an interval, and this literally means the set of all real numbers greater than 4, which is the set being described by the initial inequality. The parentheses actually say something. They say that the endpoint of the interval, in this case 4, is not a member of the set being described. And it's not, because 4 is not greater than 4. All right, so how would things change if we were talking about x greater than or equal to 4? Well, again, everything to the right of 4 would be included in the set. And since this is a greater than or equal to, x could be greater or equal, I can denote that on my number line with a closed circle. The notation I can use to describe that is given here. And this literally translates to the set of all real numbers greater than or equal to 4. So again, we want to draw our attention to the symbols at the end. A bracket indicates here that the endpoint, which is 4, is included in the set. The infinity symbol always has a parenthesis next to it because it's not considered a real number. So here are the definitions of the intervals. This first one, up in the upper left-hand corner, is read as the open interval from a to infinity. And so if I have the number a at some point on the number line, then I can draw this set as I did before. Next, in the top right corner, this is read as the closed interval from a to infinity and signifies the set of all x greater than or equal to a. So if a were here on the number line, then we can draw that set on the number line like so, just as we did before. In the lower left-hand corner, we have now a newer looking interval. Here we have a negative infinity, and this is read as the open interval from negative infinity to a. And this is a way of writing down the inequality x less than a. Then you draw the set negative infinity to a, similarly to the interval in the upper left corner, except the picture is going in the opposite direction. And in the lower right-hand corner, we have the interval from negative infinity to a closed. All right, let's suppose we had the inequality x greater than 2, and a second inequality saying that x is also less than 7. So x should be to the right of 2, but to the left of 7. And we can draw that on the number line putting open circles on 2 and 7 and drawing the line in between. We can write that as the open interval from 2 to 7. And this is what we call a finite or bounded interval. In total, we have 4 different ways of writing the n symbols when we're talking about a bounded interval. In the upper left here, we have the open interval from 2 to 7, which is drawn in blue. Brackets on the left and right side indicate that both of the endpoints, 2 and 7, are included in the set. So that set would be drawn like that. And then we have what are called the half-open intervals, which indicate that one of the endpoints, the one with the bracket, is in the set while the other is not. And those are the different, and that's it for interval notation. And that's all for interval notation. Next up, we're going to be looking at how to use this information to solve equations. Next. And that's all for interval notation. Next up, we're going to be doing what's called solving the linear inequalities.